Now that we've seen that every texture needs some sort of input, let's take a look at the different texture coordinate inputs that we have. I just added a new node, input, texture coordinate, and here you can see a range of options. These all have individual benefits and can be used to achieve different sorts of effects. There also are some common misconceptions around them, so I quickly want to go over them one by one. To illustrate better what we are looking at, I made a demonstration file that displays the coordinate map I plug in here in this main window on our Suzanne. And underneath, it splits the coordinate map into its XYZ components and displays each one individually. That is achieved with a separate XYZ node from the converter category and gives better insight into the map. Generated coordinates are anchored to the local bounding box of the object and range from 0 to 1 along each of the 3 axes. That means that they move with the orientation and location of the object. And the scale is connected to the whole mesh, so even when I go into edit mode and change the mesh, you can see that the generated coordinates stretch along with it. In the example scene, I used them whenever I wanted a texture to flexibly only appear on an object's bounce. For example, for the dust on the floor and the gradient on the walls. Normal coordinates are not coordinates in the sense of location, but rather direction. A normal vector is equal to the direction perpendicular to the surface and has a length of 1. You can see that on top of Suzanne's head it points up. The Z component is 1 and the other components are 0. Here it points into a negative direction and here all components are positive and it points like this. These normals use local space, so they are anchored to the object's transformation. You can also get global normals from the geometry input node, and they can be used to incorporate the object's geometry in a shader. For example, they are very useful to make a layer of dust or snow only appear on surfaces facing upwards. UV coordinates are the most conventional way to define a texture coordinate space, and opposed to all other coordinate spaces I am discussing here, they have the major benefit that they always stick to the surface of the object, even when it's animated with an armature. That makes them very vital for most production environments. But this comes with the cost of having to unwrap the object from 3-dimensional space into 2-dimensional space, and usually that has to be done manually. It also creates these seams that have to be hidden somehow. There can be multiple benefits to having a 2-dimensional coordinate space. You can use textures that have a preferred direction without having to worry about warping, and you can decide over the flow of the texture on the surface. Object coordinates, as the name suggests, are completely anchored to the object. They are centered around the object's origin and connected to the object's location, rotation, and scale. Object coordinates are one of my go-to texture coordinates, as they are connected to the object without being influenced by the mesh itself. So, whenever you don't need a specific property of another coordinate map, I recommend using object coordinates. But keep in mind that the position of your object's origin and the rotation and scale matter. So, if the coordinate space is really stretched, you might want to apply an object's transformation. You can also choose the orientation of the coordinates by going into the transform options and checking to affect only origins. This is a great way to change the coordinate space within an object. But you can also outsource the object coordinate space to another object's local coordinates. For example, I can create an empty object and link it in the object field down in the texture coordinate node. And now I can choose the used coordinate space without changing the main object at all. The most prominent use of object coordinates in the example file is on all the wooden elements. As you can see, the texture on this block of wood is based on the structure of an actual tree. And I can just change the shape around and it just works like that. Camera coordinates are locked to the view. So when you are in camera view, you can see that they are oriented along with the camera object. But they are in general not locked to the active camera object itself. Even when you are not in camera view, they work with the orientation of the viewport. That means that the origin of the XY plane sits in the center of the view, and the Z-axis is essentially giving information of the distance to the camera. These coordinates can be used as a depth pass within the shader to create fake mist and in general can be used to create effects that should be stuck to the view. Window coordinates are two-dimensional along the x and y coordinate of the viewport. They range from 0 to 1 and scale along with the window. When you are in camera view, they are locked to the bounds of the camera, so it looks like it does for rendering. They can be used, for example, to create a radial gradient in the world shader that sticks to the window at all times and works as a background. Reflection coordinates, just like normals, are no coordinates in the sense of location. They give you information about the direction of a ray that would be reflected on the surface coming from the viewer. You can use it, for example, to generate fake reflections from a specified angle. I want to mention one other coordinate space which is not listed in the texture coordinate node. There is another very useful coordinate type hidden in the geometry node, the position coordinates. They are anchored to nothing else but the world, and thus are global coordinates. They can be very useful to generate textures that are consistent over multiple objects and don't stick to each object individually, and also to create global effects. In the example scene, I am using them to generate a gradient of dust from the bottom up on the wooden bars and the stone walls. As you can see on the geometry node, there are several more inputs and of course a whole lot more nodes with even more inputs that you can use as a source to create shaders from. I will not go over every node and every socket that there is, but rather show you those most useful for a procedural shading workflow. Most of these I will only show organically during the course when they are needed, so if you want to look up a specific node, I recommend you check out the Blender manual page at docs.blender.org. There you have a short description for every node and socket and screenshots where it's useful. You can just use the search bar and read about the individual functionality of each node.